Hello. Yo, cool guy. Where did I go? I'm here now. Yeah, there's a lot of things happening in my job right now, so I don't have as much time to stream, unfortunately. But let's continue on here. So we did some. Yeah, we did the runtime. Yeah, being able to like call functions multiple times. Basically, a bunch of memory issues with a virtual machine. Hello, Hacker Supreme. What's up? So let's see what's happening now, because right now what I'm doing is I am testing this application here, or this program here, and if I run this, it gets kind of stuck, and when I cancel, it shows that, okay, it did echo hello, but something's getting stuck somewhere. So I run the debugger, and let's see what's happening here. You know what? Maybe. Yeah, I guess we'll find out what's happening. So we're forking a bunch of stuff. Pushing, waiting. Pop. What's this pop here? Stream, yeah. Okay, execute, right. Execute, okay. Cool, stream. Should be cat echo hello? No. No, so it okay. So what is happening? I'm not sure how familiar you are with Bash and the pipeline. So basically what's happening here is first we execute hello. And that will of course output hello to standard out. To its standard out. But then we also have this pipe here that connects to cat. So the hello of echo will go into the standard in of cat. And of course cat, what cat is doing, it's only like, it's just outputting whatever comes in. So this is, you know, the pipe to cat doesn't really do anything, you know, functionally in our program, but it's like I'm doing it to test the pipelines. Because there's something going wrong here. It gets stuck here because of some bug, so I need to check. This is just an example. The cat command should come in front, right? Why would you want it in front? What is the reason? Why? What change do you think that would make? Like if we put it in front, actually what would happen is now that cat would try to read from standard in, which is like from the keyboard. Hello will come in output, but you didn't enter what the cat file name is missing. Yeah, okay, so if you call cat without a file name, it will read from standard in. So you can't like, okay, let's say I type cat server log. Of course that will type out that will output the log to the server, to the console. But if I just type cat, I get into this kind of, you see we get stuck here. It's waiting for input now in standard in. So if I type hello, it will give me out hello. So cat received hello and it outputted hello. And if I echo hello into cat, what's happening is because we just call cat without any file name, so it will read from standard in, and it would read this hello, and it would output the hello. And another thing you can do is also, let's say you have server log, but then you want to output hello after that. You can also type this. And so first it would output whatever's in server.log. And then the hyphen here, we don't need these things, but the hyphen here, it means that it's gonna read from standard in and then output whatever comes in from standard in. So now we get like an extra hello over here. So that's what's happening here. And this stream outputted stuff, so that's good. So we forwarded that to cat, I believe. And then yeah, it says standard buff, but it's actually like echo, I think. So echo now exited. Good. Wait. Okay, yeah, the main thread is inactive, so it's like, but did it actually exited, or no, it didn't? Yeah, we're still streaming these normal things. Yeah. So where did we get hello? Yes, we did. So we did get hello. Of course, yeah. And then we also stream here. This looks like cat is still open here. Oh, did I forget to add the instruction? I'm gonna do this. I'm gonna add a command for show all instructions. Hello. Help command. Are you making a help command? What, for the Nightbot or what? Yeah, welcome, welcome. So what I want this function to do is to print like all instructions. So we're gonna loop through all the not the threads, all the instructions sets. That's right. So this is a set. No. Set, not step. Set. No, I can't. There's too many consonants for me. My language is not that advanced. Right, so that is that. Let's remove you. And we're gonna loop through instruction set, get the instruction. And actually, let's copy that. So this would print the instruction. Okay, we got our adder here. All right, I guess we'll grab the current instruction. Actually, you know what? Yeah, okay, sure. Let's grab the current. That's fine. And we'll just say, okay, well, if this equals that, we will print in this way. And then continue. Okay, so now we should see all instructions. Except we don't. Okay. Yeah, that should be. You want to learn Neovim, but brain cells can't. I think learning, like, if you're going from like something like VS Code or like any other, I guess, normal editor to Vim or Neovim, it's going to be daunting for anyone. I mean, one simple thing you can do is learn a few basic things, and then you can basically use it as any other editor, sort of. I mean, one thing is that to enter, like, you know, to be able to write text at all, you press I, or to get into insert mode, or you press A to, that's like append. So if you're here, you press I, that's insert, so you get like the cursor over here. And then you can just start typing. And then if you want to exit that mode, you press escape. And then if you want to save the file, you press colon to get into kind of command mode, and then W for save, or for write, I mean. And then if you want to quit, you press colon Q. So if you learn those 3 basic things, or 4 I guess, with the escape button as well, then you can start using it right away. Well, almost. If you want to have like a fancy config and all that, that's gonna be a whole other thing. But there are like helpers for that. There are like, you know, you can use one of those pre-configured configs. But it's also one of those things that you're not gonna learn everything at once. It's like you're gonna learn one thing here, practice that, and once you feel comfortable with that, you're gonna learn some more. You're gonna pick up things more and more, and it's like you're constantly adding to your repertoire of things. Like I don't have, like I've barely scratched the surface on what you can do in Vim, basically. Like the basic Vim commands is like, forget what plugins there are and the different configs and stuff. Just the basic Vim commands is like, it's a lot of things that you can learn there, and that's great. Press power button to turn off the laptop. No, 55% is the it's like where the screen is, I think, in the file. So it's like where about, it's like, or where the cursor is. You can see here as we're scrolling down, it's like going down. So it's as simple as that. I'm not really sure why I need that. It's like I don't put anything in this line. This is like from some sort of plugin here, and it's not. I don't really need this. Like this is all useless information almost. The only thing that's useful is like the line number, basically, and maybe the file name. But the file name is up here anyway, so yeah. Is NeoVim simpler than Vim? I mean, it's like a fork of Vim, which, like, you could say it's used for the configuration language is using Lua instead of the Vim script that Vim uses. And I would say that is an upgrade personally. Yeah, just go ahead and try it. I mean, that's how you get into it. You won't, if you don't start, you will never get into it. And I did, and you know, if you don't like it, you can just go to something else. But if you end up liking it, then hey, that's great. But also it helps, of course, to know why you would want to learn it. Like, of course, you probably have seen, I don't know, some person or something who used some weird command and it looked magical or something. And that's how I got into it as well. It's like, I don't know. I don't remember because it was so long ago, but I don't remember how I got into Vim in the first place. But yeah. Okay. So let's see what's happening here. Instruction. You want to use size. You are. Yeah, that's actually, this is I. This is J. So I and J. There we go. Wait, this is just header. Okay. There we go. So now we can see all the instructions, the whole shebang. Okay. Well, sometimes your brain needs a break. As long as you can, as long as you feel like you have the time. But I would probably try to get back to what you want to do or supposed to do there. Okay, so here we can see all the instructions. So what I wanted to look for is basically when we have a pipe stage. So this would be set for, this is the first pipe stage, I'm pretty sure. So we're pushing a stack frame, we are forking to 5, which calls echo, I believe. And then we save that result, the thread handle, and we push another handle here that we don't really do anything with, but then we pop this handle and then wait for that. And then we set keep, we turn off keep open. Should we also wait for the other stream? Perhaps. No, I mean that should finish by itself. Yeah, so this is what I was looking for. Like we're turning off like the keep open of the stream. So that means that whenever the source disconnects, it's gonna also disconnect the destination, or it's gonna close the destination. And over, what's this one? Here's like different. Yeah, because it's the last one, right? So we just inherit. So fork to 6 takes this pipe here, stack -0. Okay, that is wrong now. We have to change that format. No. Location. I don't want to flex, I just like lightweight and smoothness of Vim. I used to use VS Code and went with VS Code. I fell for the AI ID trap and was stuck with windsurf, but since last month I came back. Okay. Well, you can still use AI with, like the way I use AI now, I'm not sure if it's like, I'm a noob with that, but I'm just using codecs and I'm connecting to like MCPs to do, and that feels like I can do anything I want with that. And yeah, you have to, AI is garbage, used to waste my time, delete what is suggestion, write again, right? Yeah, like when Copilot first came out with the autocomplete, I very quickly disabled that because it was so distracting and it it didn't do what I like wanted to do. It's pretty good at like boilerplates, like, or scaffolding. Like if you tell it, hey, could you, or like you kind of direct it to do some boilerplating or something like that. So it's good in some cases, but if you don't, if we want to have a specific like implementation of something, or yeah, that's where it very often get it wrong. I mean, it might have improved now, but I just feel it's so distracting. Like I want to think for myself when I do those kind of implementations. Like if I only do boilerplate, it's like non-thinking stuff, then it's good. But yeah, I don't know what windsurf is. Is it an IDE for like using AI? Anti-gravity is old version of... Okay, I don't even know what anti-gravity is, man. Things are moving so fast nowadays. But I have heard of it, but I just thought it was like some other like agent or something. I don't know. Only it was AI running IDE such that I can chat with it and hook up the files to search code. When it's just read everything with road and start lagging. Okay. Right. Well, I kind of like it how I'm using it now. With I'm using a codex in the terminal, so no like API or anything like that. It's just calling like it. I'm running codex in the terminal, and then but then you also have to be very mindful of what you're actually asking it to do. It's like, because I went into the trap at first to think that, hey, you could solve, like, just tell it what to do. It's like this magical box that could do anything, but that's not the case. You have to learn how to work with it. You have to kind of understand what you can ask it to do and in what situation and all that, and then also do work yourself to kind of look at the code it's doing and all that. So, but also it's pretty nice now because you can connect it to, for example, your like project management MCP server and then ask it like, hey, could you give some suggestions on how to kind of start with this task, for example, that I have right now. Or you can connect it to your GitHub as well to create like PRs based on, you know, what you've done, to auto generate things. I did actually try that, but I have connected it on my work laptop thing. I haven't done it for my personal computer here, but yeah, that's pretty cool. Like you can connect it to, and you can also very easily make your own MCPs that I'm currently investigating and learning about as well. I made like I'm trying to make now like an MCP proxy server, so you only have one server that you connect to through Codex, and then the proxy server would connect to all your MCPs, whatever you need. You are in old gen yet. What is old gen? Don't you remember anti-gravity when you delete the entire code base of startup? Okay. Yeah. All right. Yeah, I don't know. Yeah, it's like, yeah, connecting it to GitHub is a security issue, of course. It could, like, if you don't have the proper safety mechanisms in place, it could potentially, you know, if you can push to main, for example, to master branch, it could like delete everything. But I guess what you could do is only allow creating a PR basically, and then you can have other securities where, okay, someone else needs to review and stuff. So it's like depends on what kind of power you're giving the AI. You should code a QR code. It's so fun to make. Oh, really? Yeah, maybe. I'm gonna figure out what I need it for, but yeah, that could be fun. Okay, so yeah, so let's see. The refs now, I need to change how they are formatted. So this would actually be like stack frame now. So this would be like stack frame plus X. Okay. It would also be cool to kind of be able to peer into memory and see, okay, what is here and what does it point to, if it points to anything and all that. So now we can see, where's the refs at? I think it's where we create like pipes and stuff. For example, here we have pipe. So this would be the stack frame, like where the stack frame is. And the stack frame here should be here, like we're creating a pipe. But this it does not make sense, actually, because it should be +3 here. I'm pretty sure. Or maybe not, actually. No, yes it should. Yes it should. It should be +3, so this is wrong. It's referring to like the standard in pipe here. No, it doesn't, actually. No. Yeah, because the stack frame... Okay, the forward IO actually pushes 3 things, and then you are now the stack frame... No, then this is a new stack frame here. But okay, we never actually set the stack frame. Ah, we never set the stack frame. That's an issue, yeah. And also, I want to check, like, what are the registers? Okay, we don't have that. Okay, let's add that command. Let's just add, like, print registers. Should we do it for the all threads? Probably. No, yes, threads. Thread. So, no, actually. So we have like thread private, and then we have all these things. So IC stack frame, stack counter is stack items length, result all right. Registers. Okay. Yeah, there you can see. And if we step now through that, stack counter is up to 3. And we step again, we push stack counter. So this is actually where we want to have a new stack frame. So when we create a stack frame, we also need to set the actual stack frame register. So we're not doing that. So we have to go to compiler, push frame, and we're pushing the old stack frame, and then we need to create. We need to do set, and location is going to be the register of stack frame, and the value is going to be well, actually this is going to be the register stack frame. No, stack counter. Yeah, so we're just setting it to whatever is the current stack counter, and that's where the stack frame begins, right? Yeah. Okay, so now we are doing this. Look at registers. We've got stack counter is 3. We push that. Stack counter is 4. Look at the stack. We can see we have 4 things. We step again. Now we set this register. And now stack frame is register is 4. What does dot mean in Zig? It means a lot of things. Okay. I mean, if you look at this, we have a bunch of different cycles. Like this dot is different from this dot, basically. Well, it's kind of the same. This dot kind of means anonymous. Or it kind of means like infer the type. So this is creating a tuple here, because we have this dot curly brace with just a value inside. So this creates a tuple. But if you have something like this dot, well, actually this is also a tuple. Yeah. Where do we have something else that is not a tuple? But basically, if you have the same thing, let's see, where do we have something else? Here, for example. Here is not a tuple, this is a struct. So this is like we're creating the type. But what is the type that we're creating? Well, we have to look at, it's kind of inferred from the argument. And this is the standard in handler event type. So this struct that we're creating here is inferred from the function, because we're calling this function, so it knows that this is this type that we're creating. So dot is kind of means that you don't have to you don't have to type in the type itself. It's like inferred from where you're using it. And then delete, dot delete is like it's the field. You're setting the field delete, the field called delete. So we're creating a new struct, literal here. It's not scary. Is star a pointer like C? Yes. and then of course this dot is just member access. There's no like arrow notation in Zig. We can use dot for everything. It auto dereferences. If this is a pointer, for example, you can see this is a pointer. You don't have to do this. You can say dot. It will auto dereference. So that's nice as well. I really like that exists. And dot continue or dot cont. This is creating an enum value. So it depends on what you return. So this return type is this event here, which is an enum of either continue or quit here. And if you return something, you don't have to type like running event dot continue, because we know it's a running event. So you can just type dot continue, and that is way nicer. Yeah, the thing that I meant here was in C, if you have a pointer to a struct and you want to call a function or set a field or something, you have to use the arrow. Now I might get some things wrong here because it was a long time ago since I actually programmed in it, but you have to use the arrow to kind of dereference what you're talking about. But if it wasn't a pointer, you use the dot. So it's like depends on if the thing you're trying to access is a pointer or if it's not a pointer, then you have to kind of switch the operator. But in Zig, you don't have to switch the operator. It will automatically handle that for you, which is really nice. Because it makes code more readable, like less, and it also makes it more copyable, like or refactorable. Like if you change this to be not a pointer all of a sudden, then you don't have to update all of these things. So that's also good. The font is Hasklig. Hasklig. This is the font here. I think PHP is like always using arrow notation. I don't think it even has dot notation for accessing. I think it's on classes or something like that. Class instances, you would use the arrow notation. Okay, good. So now stack frame is 4. Now the question is, will this magically fix the issue though? I'm just gonna run this through here and just assume that everything is fine. Okay, we're stuck on cat now. Yeah. So we can see here that cat is still running. The standard in is still open to cat. And standard out is of course also open, so from cat. So cat never closed the stream there. If we look at threads, we can see that this is inactive. So I think this just ended, maybe. Probably. Or did it? Maybe it's waiting for something? I'm not sure actually. Is it better? the Infera code or the Windows font. I mean, it's a personal preference. Whatever you think looks good, you should use. And then you don't have to stick with it either. You can change it whenever you want. Yeah, we're kind of deep in the threads. I almost said, like, yeah, deep in this. It's okay. So if I just give like an overview of what they're doing right now. So we're currently implementing a scripting language that is gonna be kind of like a bash script, like a bash-like scripting language, except with different syntax. And what I'm doing right now is I'm trying to make the pipelines work, and a pipeline is, oops, basic pipeline basic. This is a pipeline. So this here is a pipeline. Why is it a pipeline? Because it has a pipe and it has two things here. So this thing is piping into this thing, and I'm trying to make it work. It has worked before, but I reworked like some of the memory stuff in the virtual machine that is running this thing. So now I'm trying to make it work again. So that's what's happening basically. So there's something weird going on here, but I'm gonna do one thing here actually. Let's go to instructions. I'm gonna change. I think I'm gonna change this to not have a location. Or is that just gonna complicate things? Where are we creating pipes? Where's the pipes? Right, so this is the pipeline here. We're creating a pipe. We're setting an option. And we're forking that. The question is, will this be correct? This is now forked. Look at threads. We have 5 threads right now. We have the main thread. We have 3. These 3 threads are always active. They are always like streaming standard in, standard out, and standard error. And then we have this thread, which is like the first. It corresponds to the first stage in the pipeline. So this one here. And that's the thread. So if we look at instructions now, or the wait. No, if you look at the stack of each pipe, so this is the stack of thread 4. Pipe 0, pipe 3, pipe 2. Okay. That looks weird actually. Oh, what the hell? I don't know what's going on with my keyboard. It's like constantly disconnecting. No? Okay, there we go. Now we're back. Yeah, I accidentally disconnected the microphone. Okay. Yeah, there's some weird issues going on with my keyboard. It's like not... How's the audio, by the way? Is it too loud, or... Did it get louder now? I have to check what these pipes are referring to. Okay, so here we have the pipe instruction. It will create a new pipe. It then also, oh yeah, it's the handle, that's right. So this is kind of like a global pipe. This is a global handle for the pipes. So they have their own kind of space where we store them. So we add them to the context. Now this is like the global context, so they are global. So whatever number we're seeing here is like the global identifier of that pipe. It's like a pipe file handle. So you can kind of see here 0, 1, 2. Of course, that's standard in, standard out, standard error. Now that doesn't necessarily correspond to the actual file handle. You know, it just happens to be. I just happen to map standard in, standard out, standard error to the same as they are used in Linux. But this would be the same on Windows, for example, which is not the case for the actual file handle. But 3 is like is the new pipe that we created ourselves, or I mean, yeah, that we created. Whatever, maybe this one, yeah. So we created the pipe. Yeah. And so that's what we're seeing here. So that thread 4 is saying that the pipe 0 is kind of inherited. Pipe 2 is also inherited. So standard error and standard in are inherited, while standard in, or standard out here is actually this new pipe. No, I mean standard out. I mean standard out is this new pipe. So it means that whatever this thread is like executing something that would output to standard out, it would output to this pipe here instead. So that is correct. Oh, and of course I need to also print what thread we are referring to when we're listing these things. So this would be thread something. Let's actually do 2 at the start so we get a little bit of different. Yeah. Okay. Now we can see all this crap. Okay, I want to do another. I want to do one more thing here to the debugger. Like when we're printing instructions, if the skip IO is on, I don't want to get the current thread. I want to get the next thread that should execute. There should be something like get next active thread, yeah. But that is not public. But let's just make it public. So this should be like get next active thread. Except this is a number. If we don't have one, I guess there's nothing. I mean, if we don't have one, I guess we could write no active threads. But this is like the thread index, and then the actual thread would be threads. No, wait, that's the thread ID, right? No, it's the index. Yeah, it's the index. So this would be items thread I. There we go. Wait, this is the wrong thing. Oh. This is the one that I want. There we go. I think the cache, yeah, is this a red switch keyboard? No, it's, I don't know what it is. It's a standard mechanical keyboard. Yeah, look at how long it took to remove that. That is a sign that is why we got the error. I mean, it's like when you develop in Zig, I think there's an issue here because it's like the Zig cache is every time I update a code, like I write some code and then compile it, there's gonna be a different version in the Zig cache, and then there's no end to that. So it's like at some point it fills up the entire drive, so I have to kind of remove the cache and continue. But I guess the good thing is that we are able to actually remove the cache. Also, what I had some command to check the disks. I forgot what it was now. Something N. So then C. What is this? No. NCDU, that's right. Yeah. Oh, but this is like, this is only in this thing here. But yeah, so that you can use that. Yo, Penguin, what's up? You might have a use for anti-gravity agent. It's amazing at cleaning. No, but yeah, the problem, I just explained the problem. The problem is that the zig cache folder is like, there's no cap on, there's no like, okay, at some point when it's too large, it will like remove old, you know, versions of the thing. Like each time I save, it compiles and a new version of the program is like stored in the cache. So, and you know, over time, of course, that will grow a lot, and it will take up the entire disk. So I just have to, that's the only thing that's like takes a lot of space. So I have to kind of just remove that once in a while, but it's fine. Oh yeah, so let's do try and then continue. Instructions. So now if I type instructions, we get this, and if I step after these forks, let's say I print instructions now, we're still seeing thread 1. Oh, I see. Wait. Okay. So that was kind of stupid. Actually, what if we said, what if we added like an index here? Which is null. So if it's null, we're gonna grab it. Or I mean, yeah. And then maybe we can adapt this later, but I'm not gonna. It works now. I'm not gonna touch it right now. So now here, instead of null, we would say what would be the current thread index is going to be. So if we have like, if skip IO is true. So basically what I'm doing here is like, we have this option skip standard IO, which skips the first 3 threads except the main thread. And when we want to print instructions, we don't really want to see those threads. So I have this special case where if you skip those, it's just gonna not show those at all, basically. It's going to show that it executes them, but it's not going to show. I don't want to see the instructions of those threads. So if this is true, we want to, and the current. So let's do like, if this is true, and if context, if the thread is let's do like more than or equal to 1, and is there like a like between? No. and let's say equal to 3. So those are the kind of the standard IO threads, so we'll just skip those. So if it's between those, we're gonna say right. We're gonna say actually, you know what? If there's no next active thread, actually this means that we actually have, this should be 0. Yeah. Because it wraps around to the main thread, but it doesn't actually show that. But the main thread, I mean, it could be. No, okay, let's do this. Let's do this. Perhaps. No. Okay. Anyway, so we skip standard IO. If the thread counter is between 1 and 0 inclusive, that means we wanna get the next active thread. No, that means that this should be 4. Otherwise, it's gonna be null. So either we're doing like after these threads, or we're null, which means we should take like the current thing. And I know it looks horrible here, but yeah. And then so this else is like inner. So we need to add another branch. Okay. It's just so I can have this constant here. We could move this to a separate function instead, but whatever. All right, let's see if that works. So if I type instructions, we see that. Good. Once we fork, I'll type instructions. So now we see the instructions of the main thread. But if we look at threads, we can see that the actual current active thread is the if thread 1, but when we type instructions, we still see thread 0 because we're skipping these things. So now we have 3 threads. Type instructions, we should see main thread, because that's kind of the thread that's actually gonna get instructed, because we are kind of we're kind of skipping through these until we reach a thread that is not skipped, basically. And then we have the ref pipe. We create a pipe, and now we fork. But now we should see number 4. There we go. Cool. Okay, so now we're stuck. Like, if I press continue here, it's gonna keep going. So you know what? It would be cool if you press Ctrl C, like you get an interruption signal while we're in continue mode. It doesn't like exit the program. It would like you know, just exit continue. I'm just thinking what else we could do to make this more good. I think what I want to do is I want to see, like, let's say we enable kind of like a window over here that will print out the current, because we rarely go into here, and if we do, it's like it's not really, we don't really care too much about that. So I'm thinking, like, if we enable, it doesn't have to take up the whole thing. It could just take up like some here, but it would show. It would be nice to see what kind of different threads we have, what the registers are, and maybe some of like the stack. So okay, let's have print. I'm just gonna have like print window. The problem here is like figuring out text wrapping and all that stuff, but what if we have content? Hang on. No. Don't we have like print location? Print at? Location. Position vector. I forget what we have. Terminal vector. There we go. And then do that. I thought we already had that, but maybe not. So this would be like print. Cursor set. Oh, I guess we could use this. So we'll get it, and then in the end we will restore the original position. And now we do print format args. Alright, so very basic. We just print something at another place. Yes, I'm writing a debugger for the language. Alright. Well, no catch needed. So basically the error that happens is like a writer error. So if that happens, it basically means that, hey, it basically means that we can't write to the console, and then, you know, it's kind of like, yeah, this print function, I guess you could say that it kind of inherits this this thing here. So in Zig, the error handling is returned by, or an error is returned as a value. So basically what's happening here is that this means that we are, if you don't have try here, this will be a compiler error. Well, now it's not, because we're not using this function, so it doesn't actually do the check there. But if I do this one, for example, I remove try, this is now a compiler error. Come on, there we go. Error union is ignored. And why is that? Because all errors needs to be handled. And either you can handle it by saying try, and what that means is basically bubbling this up. It's bubbling up to whoever is calling the thing. But we do have to kind of manually say that, yeah, this is gonna bubble up. So it's very visible that this statement here is going, or expression is going to could have an error. You can also have a catch, and it's very simple. It's like if this returns an error, we execute what's in the catch instead. And you can also capture the error itself if you're interested in getting well, now the LSP can't actually see what type this is, but it's an error. The error type that is returned from this thing here is kind of like inferred here. So the error is actually, it's like embedded in the type itself. Yeah, and there's no like throwing errors in the same way as it's like you're returning an error. It's embedded in the type. So instead of returning the value that you want, you actually return an error instead. So we can return some error. Now we're returning this error here instead. So there's no, and that also means that there's no hidden control flow when it comes to error handling. It's all explicit and visible, which is very good. I really like that. I know that Java has a good also, like it does have like exceptions, but it also has the throws keyword so that you can see what the function will throw, or what it could throw, I mean. Because it's always like, I think like in C#, for example, you don't actually know, if you call a function, you don't know what it could throw. You kind of have to know, or read documentation, or check it somehow. But here is like everything explicit, which is really, really nice. So error handling is a lot easier because you know that, okay, well, this could be an error, so let's actually handle that here, for example. Or bubble it up, like, but you have to do it somehow. If errors needs to be handled here, like a custom error response, you use catch, otherwise use try. Yes. It's kind of like it is like throwing, except there's no hidden control flow and everything is explicit. Which I think, from using this, I would prefer this like every time over hidden control flow with exceptions. But hey, it's a preference as everything else. So, but you know, if you have like the only thing you have to do is like if you bubble it up, you have to add a try. So, and even the compiler will tell you, hey, add a try here or whatever. So it's not really that big of a deal. And it's very visible what can go wrong and what can't. I mean, yeah. So So that's that. Now we have this print at function. Now what I want to do is, it would be cool also to have like a wrapping thing to be able to print something as a wrapped. And I think what makes sense is a text wrapper formatter. So text wrapper formatter, text wrapping formatter. So we'll have like some kind of width. And then you can have a format function. The problem is though, how would we... I think we could do this. Like if this is a function, we take a comp time t, any type, return type, we'll make it generic. And then we have, let's say, and then this would be format is a comp time string, and args is t, and then we'll have like wrap text or text wrapper. We will get, so this would, so let's do like IR debugger. Actually we don't really need IR debugger. We can do comp time format string, and then args anytime, and then we return a text wrapping formatter that takes the type of args, and we return this thing, and the width will be something. There we go. Okay, so the idea is that this would kind of be able to print this. However, we also have a formatting thing, except this. I mean, it would be nice if we just had a string. Want to crash the program? We just return the error burned in the caller to handle. I mean, yes, you can bubble it up to the main function as well. You can bubble from the main function to a global handler that is like a default handler that is registered on all Zig programs. But you can also, you can change that handler as well if you want. So, I mean, it is kind of the same thing as exceptions, except it's like everything is explicit. You can see every function that can potentially throw an error, you have to kind of say try on those, or catch the error and handle it. But it becomes very visible. And it also reminds you that, hey, maybe you should catch it here, Yeah. And also you get like the error type. The error, you can kind of switch on the error type as well. The only thing that's that I kind of miss is lacking here is like when you throw an exception, you can include other information in the exception type, but here you can't in this error system. So this is in this error type. So this error, the errors are only like, they are kind of like static strings, and that's the only thing, that's the only information you can get. You get about like a static string basically. So this error right here, if you look at that, it has like write failed, and that's essentially just a string that has write failed in it. So that's the only information you get. But you know, from context you can kind of get more information. Also, I mean, there's other ways to handle it as well. Like you can return you can have a result type that has that is like a union enum, a tagged union, that you can say like, okay, either it was success with the payload or it was an error, and then you can actually include whatever data you want. So this is like a nice way of, you know, I mean, I think it's really nice. The only thing it could maybe improve on is like adding data to these, but it's not like it's impossible to have errors with data. It's just that the built-in error is, the built-in error type is essentially just a string. Okay, so how would we want to do this? Maybe it's better if this is just a string actually. Let's actually just do that, yeah. Text wrapping formatter. Okay, let's do that instead, and then you would be the string. Maybe there's another way to do it, but and then here is basically, we're just gonna say, so how long is this, like how many lines would we get? So let's do, we could also do like, the thing is, if you have like things like colors, new lines and stuff in the text, it will also complicate things. But for now, I think I'm just gonna say that how many lines are we gonna get? So that would be like div floor or something, or is it ceiling actually? Do you work for integers? Yeah, I guess. So you would be length, and then you are width. Yeah, you can see this is an error type. So we have to say try here, except we can't, because this error here has to be a writer error. So what we can do is we can say catch and just have one line, I guess. I don't know. But then we will loop through the lines. Good to get errors in strings, so pay from is a type, define type of error, and according to, yeah, I mean, it's really nice. It's really easy to define errors. It's just that when you want to get more information about the error, like what went wrong, and like maybe get like some context to it, then you have to do more more things. But yeah, usually it's enough to like with the context of what's happening and be able to see which error happened. But yeah, there are ways to you know, you can have like an error field that you set, or you can return some kind of error like tagged union instead and stuff like that. You can have error types. You can have like a struct with errors, like you can have an error here. So you can have like any error, for example, that would be able to hold any kind of error here. So, or even you can do like optional any error. So if this is like, let's say this is populated, if this is not null, that means maybe that we got an error, and so on. So you can do a bunch of stuff. 2048. What do you mean? Maybe filter that ignores or removes. Yeah. Yeah, but there's also like the new lines and stuff like that. So I'm just gonna do a very naive thing here where I'm just gonna say the lines here, and it's not gonna break on words or anything. Now we could do that. Maybe the word thing could be one thing that we do, but I'm just gonna say so this will be like write all, and then s, and then we have, now we should have like I times width until, I guess, so let's do start is I times width, and then end is gonna be start plus width, right? Now there might be one of error somewhere here, but yeah. Okay. So now we can make a text wrapper, and this would be some kind of error, of course. So we need to create. Actually, let's add self here, because we need to actually create the string here. So this would be like allocator. This actually there's a format function alloc print that we can use, and there we go. Actually, do we have like a frame arena or something? No. And we do that. We could add a dinit function. Since we're allocating s, let's add a dinit function. Alright, now you're not format args anymore. We are saying .s equals s. So yeah, so we're doing like alloc print, and then we're returning a new thing here, except you don't have a thing there anymore. So if you call this function, you get a formatter that would format this string as in these lines. So it's kind of like a pseudo window, very basic window print thing. And then we can add like print wrapped at maybe position format. Oops. So wrapped, and then we do width, right? And what we do here is we do try self print at position, and then the format's gonna be format, except it's gonna be like f, and then here we're gonna say text wrapper with format args. Oh, but I'm gonna actually do it here. Because what I want to do is after I want to deinitialize. There we go. All right. So we're kind of allocating this string here, and then we deinitialize it after. So I mean, we don't have to use the heap allocator. We could use like a stack-based allocator as well, I guess. Because it's kind of like, what's good about the writer is that once you've pushed data through, you don't need to keep it anymore. So we can just keep it on the stack temporarily and then push it through and then be done with it. But then we have to pass like an allocator in here, I guess. Yeah, so what you could do, it's not that hard actually, but you do have to pass an allocator instead now. And that's fine, we just add that. And then here we create a stack fallback. No, fallback. Where is this thing? Oh, allocating writer. Oh yeah. I can. Yeah. So this is what I was thinking. Like, you can make an fallback allocator like this. It's very simple. We make, so it's basically saying that, hey, we want to store. This is only 128, but basically you can make it like anything, like let's say 1024. So now we're saying, hey, allocate 1024 on the stack instead of on the heap. So this will be on the stack. However, there's a fallback. So if we exceed the allocation of a kilobyte, we would use the normal allocator, like the fallback allocator instead. So you create this fallback allocator, and then that would kind of avoid having to allocate on the heap. We would use the stack first, and then we get this allocator here, and now we can pass that in here, and there we go. And then we don't even need to deinitialize this. We don't even need to worry about that. We can just say, well, actually, we don't even need to deinitialize here either. Yeah, because this is going to be on the stack. Actually, we kind of do need to do that. I mean, let's say this did use more than the stack allocation, so then we would actually do need to deinitialize it. But now, potentially, most of these would happen on the stack. So that's more efficient, I guess. Maybe. I mean, we have to set up this whole thing as well, but I think the most expensive thing is when you have to allocate on a new thing on the heap. In the case of this port here, but this should be fine. Okay. Yeah, so now we have this thing. So basically you can provide a position where you want to print the width on, like the maximum width on where, like how large the window is, and then the kind of string that we want to format. So yeah, but it's not word perfect, but let's try it out. So let's add a command. Let's add like a setting. We should start having these as maybe like settings struct or something. But let's add what would this be? Like what I want to show? I don't know, info window. Show info window. Let's have it true actually to start with. Okay, so let's add a command to toggle that. One second here. All right. Yes, let's add a command. Toggle info window. So let's add that there. So this will be like, I don't know, info. I'll just call it info. That's fine. Okay. So we need that function. Toggle info window. And we basically set show info window to not show info window. Okay. And then and now we need to show it as well. So let's see. This is going to be interesting. How do we actually do this? So we have a loop somewhere. So yeah, here's like the main run. So basically, the debugger is like running in a loop. So right now it's like we have this while loop, and we have this. It's kind of like a game loop, and then we run this loop function, and we get back like a run event. And if it says quit, then we exit. If it says continue, we continue. And the loop function will just do stuff. So update command is kind of printing out the prompt, you could say, and showing the command at the bottom. And then the string you put in here is actually like if you want to append something to the current command, but we're saying nothing here, so that's just gonna print the command at the bottom. And I guess if we have a window shown, we could add it. We could add the window here. But we probably want to do it like at the end of the function. So actually, we can then move this part into, yeah, let's move this entire part into a separate function that would be like command input or something. I don't know. What would this be? Read command input or something. Yeah. All right. And after we've done that, well, we get the result back. And we return that afterwards. But after we've done that, we want to print out, like if show info window is on, we want to print that window. So we want to print the info window, but we don't have this function yet, but let's create it. All right. Now what is gonna be in this window? Let's just start with printing out all the threads and their registers. So we'll kind of loop through all the threads. So evaluator, context, threads, items. All right. Okay. Okay, so let's see. I mean, let's do like print. What the hell? Yeah, sorry, I just got distracted. Okay, anyway, so let's do like print print wrapped at, and we're just gonna try this out. So the position, what is the position actually? Let's grab the size of the terminal, and then the position will be, I don't know, what would be like the window size? Or width. Let's say, I don't know, 30 characters maybe? So this would be like, so let's do like info window position will be size so let's do a term vector. So x, so, or well, the row would be 1 and the column would be size column minus that. However, it could be overflowing or underflowing or whatever it's called. So we do that. So that's the position. Okay. So this would start there, and then we probably need to add, like, let's say the next thread is like on the thing below, so let's add, I don't know, no, let's just do this for now. We'll see how it looks. Okay, and the width is info window width, the format, and argument. So what is the format? So this would be like I don't know, thread. Let's do I for ID, or should we do thread ID actually? Yeah, thread ID makes more sense. So let's just see what this does, but I do think we should probably add an index here. So let's do like add I times 2 maybe. So that would kind of, the first would be at the top left, the second would be 2 rows down, and so on. Oh my god. You are gonna do that. There we go. And okay, let's see what this does then. Of course, we need to try here. And you are a, okay, well, I'm just gonna do a cast here. That is also one thing that Zig does. It also, like, all casting and stuff is very explicit, which is good because it shows that, hey, there's actually work being done here to do this. But it's also, like, kind of annoying sometimes. But you kind of have to learn how to, well, not really get around it, but more like work with it, I guess. And this is also could be thing. View, of course, also can be an error, so there we go. And view can be an error. Okay, so let's see what this gives us now. Okay, we got a crash. Great. Out of bounds. All right. So let's look at the formatter. So what's happening here? We're dividing the length of the string with the width of the thing. And that's how many lines we need. Oh, I see, except for the end. Okay. So the end we're gonna do like maximum or minimum, I mean, of this, and then length of S. Okay, so we get the window up there. Cool. Now let's also write out. So we got thread, and then I'm gonna do this. I'm gonna write below. So this would be like +1. And this would be registers, so we would have like instruction counter, stack frame. I'm gonna do this to make it a little bit shorter. Stack counter and the return value. So this is going to be private instruction counter, stack frame, stack counter, result register. There's an error somewhere. Why is it so slow? Oh yeah, this one is F. There we go. Okay. Okay, it it didn't really work. It goes through here. Wait, how many characters is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 30. Interesting. I mean, what if we say, what if we lower it a little bit so then we can maybe more easily see what's going on maybe. Okay, so it wraps it over there. Okay. Well, I kind of see what's going on. This won't really work. I mean, what we're doing here is basically what I wrote here before was basically just, hey, we're writing everything, except we're just writing it line by line, but we're not like including anything like moving positions or anything. So it's just gonna write, you know, the first line, and then write the next line directly after the first line with no new line or any positioning happening. So of course this is not really going to work. So what we need is we need to have some sort of, we need more information to be able to do this. So I don't think a formatter is maybe a good fit for this. Unless we could, I guess we could provide a position where this would end up. I mean, we can also say get cursor position here to try and see where we are before the first line. The thing is, why do we really need self? Because of write all, that's right. I mean, really what we need is the writer, like a writer and a reader. Because we're writing out this and then we're reading in. We're using the reader to read in stuff, so we could make this, we could generalize this to work without having to pass self here, but the problem is then that we don't really have a reader though. I mean, I guess we could add a reader to the text wrap. I mean, yeah, let's do this. I'm gonna call this gen for generic. So you take a reader and a writer, and then the writer will write all, and then this would be reader, and that's it. And then over here we would say, okay, well, return get cursor position generic. This would be this writer here, and then the reader would be reader. well, it's standard in reader. Oh yeah, so we have like standard out writer. There we go. So then we can do that. And then we can call gen here. We can also supply a reader that we can use. So you would be the writer and then self reader. So now we can actually get the position here. So we don't need to supply a position. And then we have to supply the reader here. So that's just going to be like self. Oh, now we actually do need we need a reader. Well, that's fine. Okay, so now we can get the position here. And of course you are like a reader writer error. If we can't get the position, I'm just gonna say it's at the top left. Okay. Or I guess we can also say it's null. We didn't get it. So then what would be the start column? It's gonna be if position column else one, I guess. All right. And each line we want to now we want to set the cursor position. Let's make a generic version where you have a writer, and we'll do writer print instead. There we go. And so here we're gonna set the position. No. Using the writer, and the position is gonna be row. It's gonna be 0, I guess. So 0 means the current row. So the row is not going to change. What I'm thinking is that we could write a command that actually just moves the cursor down one step. So maybe like /n. Actually, we could do this. We could do print. No, write all. And then write byte, new line. And then we set the position to the current row, and then we just move the column. Yeah. It's just to handle the case where we don't have a position. And like, if we can't do this, we probably can't do everything else anyway. So it's like it's kind of unnecessary, I guess. But it's like, I don't know. I just wanted to try and fix and do this here. So we're writing this and then a new line, and then we're just setting the column to go back to the starting column. Okay, so does this work? No, I thought 0 meant nothing. You can also do that. Set column but the weird thing is it's like it doesn't even show the prompt at the bottom now. Okay, there's something weird going on there. Also, we can just do return set curse position gen standard writer. Position. Oh, yeah. We need to flash. Yeah, okay. So it's like so basically I had this write all function, self write all here. This does the flash here. So we're flashing. I'm not sure why I did it like this. I mean, really, this should be just try and then flash after. It's kind of weird. Yeah. There we go. But really, we're writing and then flashing. So I kind of included that in the print and write all. However, just to make it more convenient to use. However, now when we switch to a generic writer, which could be any writer, we also have to print that, or flash, I mean. There we go. Okay. Don't forget to flash. There we go. But we don't see the window now. Oh, because I disabled it, right? Okay, there we go. Okay, there we go. Okay, now we can see some funky stuff happening here. It goes back to like the first row, I guess. Okay, so what's happening here? We get the number of lines. We do this. We get the position. Presumably this would be correct. Starting column is the column of the current position before we write anything. Yeah, that should be correct. And then we calculate, we get the line. Just to make things a little bit more clear on what's happening. We're getting the line, we're writing the line out, and then we do this to get like down ones, and we set the column only to this, which should just move the column back to starting column and one line and one row down now, right? What if we say like 5? Okay, so we only get like the 2 lines. It's like, it seems like it starts here, and then when it gets over there, it goes up, and then does everything on this line. There should also be a way to kind of just move down. You know what? Let's do this. If we can't get the position, we're screwed anyway. So I'm just gonna return at that point. So now we should always have the position, and that should be like the start position. I'm just gonna do this, and then we set the position to be row. It's gonna be position row plus I. Column is gonna be position column. So I mean, basically it's just gonna be position add I0. Can you coerce to I size? No. So we have to do int cast. Oops. Okay. Does this work? Make sure we're okay. There we go. That looks better? Question mark. I mean, it's kind of hard to tell. THREAD. D goes back there. The hell? Let's do this. How does this look? Okay. Thread 0. Yeah. It kind of goes back to the same row. For some reason. Like, we're not modifying it to be like 1 or like -1 or anything. We're just getting the thing. And adding I Oh, it should be +1 here because we're doing it at the end. Right. I mean, or we could do it here, I guess. I was thinking of doing it at first, but okay, sure. Okay, there we go. Now it's like wrapping. And now we come to the issue that I was talking about before. It's like, it's not really word, you know, it's not keeping the word intact. It's kind of breaking. Yeah, it doesn't have like word break, as is the lingo maybe. Also, I want to remove those commas. Maybe even have that as separate. Yeah. So what I want to do is I want to make like a word, maybe like a iterator. Somehow being able to do that. So let's see what we can do. So there are a number of like built-in iterators. So there's like split iterator, for example, split on iterator slice buffer are separated by the limiter. However, and this would technically work, I think. So if we do buffer is going to be S, delimiter is going to be space. So here's our split iterator. So this is kind of like a word iterator almost, we can see. But it's not really a word iterator because it also like has I mean, okay, so let's say you split a word like this. So of course if you split it like this, the first element of this iterator is going to be this. Yeah, makes sense. And the second is going to be this. However, if you add another space in here, what's going to happen is that you're going to get an empty word here between. So, and that's good actually, because we might want to actually have that space there. Or, I mean, we can also say that, hey, if you have a multiple spaces, just like HTML, like standard formatting, it's gonna collapse to one. We could also do that, and in that case, you would use something like tokenize scalar, and that would do that. That would actually turn this into, you know, two iterations, like just first and second. So it would kind of just skip all this and you go straight to that. But for split, it would actually create empty elements for each thing separated by a space here. But this would just skip everything. So that might be, we might just say that, hey, let's just format it like this. Okay, so now we got our iterator for that. And then you can iterate doing this. And we get our word out. Now, I think what we need to do now is change this a little bit. We don't do lines anymore. What we do is we keep track of where our index is. So we'll start at 0 and we'll say if word length plus index is more than or equal to width. I guess if it's equal, it should fit. So let's do like if it's more than width, what we'll do is we'll, you know, advance the cursor, advance the line. So let's have J as the current line, just to make it confusing with the naming. We increase J by 1, and now we want to grab out the line and write that, and also set the position. So set the position to be starting position plus well, this would be like J, and then what would the colon be? Now, see, we only want to do that here, I think. Yeah. We'll reset it back to 1. No, that. Yeah. And then we take, well, start is going to be like I. No, actually, we don't really need this at all. We just write the word. Yeah. However, we do want to do this, like else. I mean, we do want to have a space somewhere. So where would we write a space? I think we just write a space after here. Maybe. Or do we need to check? So what we also need to like add the word length to I. And then we come around and it's like if this is always the issue with these loops, is like if you want to intersperse as it were, like something between each element but not at the end or at the beginning, it's always gonna be like, yeah, you always have to kind of deal with that. So here's like, yeah, we want to add a write byte at the end. However, what if we're at the end of the terminal and we write a space? That would, I think that would like roll it down and loop down over here. So now we're all over here, but we didn't mean to be over here. So I think, do we want to check this again? Word length plus I. Actually, this is just I now. So let's do like I plus 1, because that's the length of the word of the space. If that is more than width, actually, if it's less than or equal to width, we write it out. I think, because it's like, let's say width is 5. We have a length of 5 of the word, plus I is 0. We should that should fit in the width, yeah. And then down here is kind of the same thing. This would be 5 plus 1 is 6. Is less than or equal to, let's say it was 6, then it would work, yeah. Okay. So that we write the thing there. And I think also this means that we should also increase this by 1. So we're kind of writing out the delimiter, an extra thing there. Okay, cool. And we can remove that. We'll remove you. Okay, so now we should have like a word capable thing, perhaps, maybe, we'll see. Okay, Except the last thing, the last one does not seem to work. So I think what's happening is that we forgot to reset something. Oh, right. So I is actually... We should reset I here then to 0. It's kind of like our... Yeah, the column counter. Okay, there we go. So we got word break wrap now. Cool. Now it would be cool if we could just continue actually. Like we get the position after and we say, okay, so now we get the row where we ended and we continue writing the next thread, the next thing below. Because right now if we run this and we spawn a bunch of threads, you can see that it's like overwritten over here, like it hard-coded 2 steps down. So what we can do is we go back to here and we do print info window. I mean, there's also like you can use libraries for this. I just like to build these things myself. Of course, you can do this the easy way as well. Although then you would have to learn how the library works. So there's always a cost. I don't know. I just find it fascinating that you can do this. I mean, I kind of recently learned about the ANSI code, so now I want to explore that and just do it myself first, and then maybe use a library later when I don't want to do this myself anymore. Alright, so after here we should have some kind of row. So let's get the new, let's have like current position is, I'm gonna say it's like undefined for now, and then current position is gonna be get cursor position. Oops, what the hell? Okay, so we get the position. We could just set it to info window position actually. Okay, so instead of doing this and this, what I want to do is do current position instead, and then add 1 to row. Well, actually, you know what? This would be interesting because technically we could get another here. So I'm gonna do this. And then also roll back the column to the start. Yeah. So that should be that. And then I think I just want to... Actually, we're just going to add, actually. We're just going to add... No. Yeah. No. Row. We add 1 row. So this is kind of like how the immediate renderers work. It's where you have like a position that you constantly update, and then the next thing you would just use the current position. So current position, we get it after. That should stop at like the last line where it actually wrote, but then you have to move down 1 step and you have to so this is kind of like a new line within the window. And then we want to do the same thing here, except maybe do +2 so that the next thread will have a little bit of space in between. Oh yeah, sorry. This should be +=1. this row back. There we go. Okay, and then we don't need this. Fine. Okay. Interesting. Now that disappeared. Great. Okay. I am confused. So you should stop. Wait. No. You're stopping like... I mean, worst case, you're stopping here or you're stopping here. So you're stopping at the same line, like at the end where we write. So when we get the position after that, we should get... we should get the thing. Print at. Yeah, they should flush and everything. Oh, because print at restores the position. Maybe we shouldn't do that actually. Yeah, let's just not do that. Okay, there we go. So that's that, and then we say we step through. Okay, so you can see here that we got an issue here now, but that is because print info window. Yeah, so actually here we need to get the original position. And then at the end we restore it, so there we go. Still looks weird, yeah. Or maybe not actually. This is fine. This is weird though. This, I'm not sure why we get the void up here. Oh yeah, we're never clearing this. We don't clear this. I see. Okay. Okay. So I guess we'll clear the window all the way down to the bottom maybe. Height is gonna be like size row. And so let's do like a clear I guess area. We're kind of building like a little 2D renderer here. Area, let's do vector and void. Okay, so actually I'm not sure, is there like a built-in thing for this? I'm gonna Google, do a quick Google here. ANSI code clear area. Clear entire. So there's one for clearing the screen. Okay, there's gonna be a bright window coming up, so you've been warned. 3, 2, 1. There you go. Erase in display. Clears part of the screen. If N is missing, clear from cursor to end of screen. If N is 1, clear from cursor to beginning of the screen. If N is 2, clear entire screen. If N is 3, clear entire screen and delete all lines saved in the scrollback buffer. Right. So I'm thinking what we could do is we could do erase in line. And we're looping through all the rows, maybe. Well, I mean, that only works if it's like at the end of the... If the window is like at the end. We could also just write a bunch of spaces. But this one erases part of the line. If N is 0 missing, clear from cursor to the end of the line. If N is 1, clear to the beginning of the line. If N is 2, clear entire line. I wish there was like clear from X to Y, but I don't think that exists. Okay. So clear area. And we're gonna assume that this area, well, okay, so we need a position, of course, as well. Position. It's like a rectangle. Position is gonna be window position. And no, not the size. Actually, let's do like info window size is equal to term vector row is size row, column is 20. There we go. So this would be size column. All right. There we go. So, oh yeah, and this would be size. Okay. Now, we're just gonna loop through from position row to area row. Actually, position row plus area row. So that's the row. And then we're gonna say, we're gonna create perhaps I'm just gonna do this. Buffer. This is also another way to kind of do a stack based string. So you create a buffer on the stack and then you use format buff print and you provide the buffer, and the format is basically a space. No, wait. No, actually, let's just create the buffer and then we loop through. I mean, you could do this. You could also like just write a byte, but that feels like there's so much overhead. Isn't it more efficient to create a buffer first? Or is there like repeat or write byte preserve? What the hell is that? Oh yeah, you can do right splat. That's right. Yeah, right splat. So splat is kind of like you can repeat the last thing. I'm not sure what's like better if you're doing like right byte and just repeating that, or right splat. But this is basically you can do. I just want to do like a space, and then this would be how many. So this would be like area column. So that's how many we're gonna do. Why is this not? Oh, yeah. So what this is doing is taking the last item in this array, which is, we only have one item, so it's just gonna take this item, and it's gonna write it this number of times. Okay, so that should clear that line in the window, and then I guess we do like a set position to be like position add I. So let's also keep track of I here. Okay. But now also we need to make sure that we write at the position that we want. But we should be doing that anyway. We'll print wrap that. So we clear the area, because every time you write something it's changing the cursor position, right? Of course. Okay, so we're going through position row to the end in the height, and then we also keep track of the index that we then add here. I mean, we could also say set position. Yeah, okay, this is probably a lot better actually. We set the position, row is row, column is position, column. Because we could have some other position first that we don't want to. We need to set the position for the first line as well. Okay, cool. And oh yeah. Okay. Man, this is annoying. Like this returns how many we could write. I'm just gonna ignore this and assume it all went to plan. And then of course we also need to flush as well. Okay. Now we don't need this I here. Good. Okay. I think that should clear the area. I think let's just try it. Let's just say do like a dash or a dot or something, so then we can really see where this window is being kind of drawn. And there you see. Cool. I mean, we could also do like a border thing to make it look incredible. I mean, I'm almost tempted to do that, but let's just do space for now and see if it looks better when we kind of step through here. Yeah. So here we can see that R was actually we see that, yeah, it kind of looked weird. I thought that this was a bug first, but R is actually set to a value, which is a thread handle. So that is this, because R is like the result register. Okay, and we can kind of see here the spawns there. Now these three has kind of settled on IC line 2 of their respective instruction sets. And now we forked a new thread. Pretty cool. Okay. And then now we're all of a sudden we don't really see anything anymore. Okay. So good. That actually showed what happens if we get to the end as well. Okay. Now I want to increase the width a little bit, so we can just say like 35 or 40. Is there actually an error in here? No, it's not. Okay. It was just a bit slow. Okay, now it fits like on one line, so we could fit more threads in there now. There's gonna be a lot of threads. I mean, and also these 3 threads are not really, we don't really care about these 3 threads. So I think I'm gonna just ignore those. If skip IO is actually it's on, we're gonna also hide those threads. So what we're gonna do is we're gonna say here, if skip IO is on and thread ID is more than or equal to 1, or and thread ID is 3, then we continue. So now we don't see those threads because they are kind of always there and doing their thing. Cool. So that's one view. Now it would be cool to be able to see like each thread's like memory and stuff as well. Yeah, and now we're stuck here. I'm just thinking like, okay, what could we now show? We don't have enough space in the window to show everything. Like it would be cool if we could see the stack and stuff as well, but it's gonna be too much information, so I'm not sure how to do that. Also, let's just add a divider. I'm gonna do draw vertical border, position, actually this would just require a column actually. Let's also provide a height if we have it, or we should have it. So I'm just gonna do this, and then do like set position to row is I, column is column, and then write a pipe. Okay, and of course this needs to be a try, and then we'll do clear area. After we've cleared the area, let's also do the border. Column is gonna be position call of -1 height is that. You know what? Let's just take a position. So this would be position, add -1. Okay. So now it's we get like this border here. Okay. So what's happening now? Let's add, if the thread is inactive, I'm gonna add s if thread is thread active, then this will be something else. If it's active, we don't show anything. If it's inactive, we're gonna say inactive. Will this work? Oh. There's an issue somewhere. There we go. Complex. There we go. And I guess we can say is active. Now we're kind of seeing when they go to sleep. So now we see thread 0 is now inactive. It went to sleep. Or yeah, it's waiting for something else. I mean, I guess we could also try to, we could say that it's like waiting for, like what is it waiting for? Which we have here. So it's waiting for, I think this is an ID. So waiting for, actually let's do this. If waiting for, we will say waiting for that. No. That doesn't work. We would have to kind of print that. Yeah, that doesn't work. We kind of have to do this, like if waiting for. Unfortunately, well, this is one way to do it, like waiting for, and then we add, whoops, what am I doing? Waiting for, Okay. Let's just do this. We don't have to do that. Else if is active or not is active. Well, now we can actually just say else. We could have two. We just have to have two prompts here. All right. We could also like have a prefix, or I mean a suffix created before and then just add it in instead of doing all this. And that will basically be, you know, we're checking this, we get waiting for, then this would be create a buffer. This would be like format buff alloc or buff print thread suffix butter buffer, and then this would be waiting for that, waiting for, otherwise else if is active, we get nothing else, we get inactive. Yeah. Oops. So now that's just a, well, I'm just gonna catch unreachable there because that shouldn't happen. So this is now a string, and then we can simply use it. Then we don't need to do this part. We can do thread suffix here. Okay. Yeah. Oh, there's a space. There's a space missing there. There we go. There. There we go. So now we can see that this is waiting for thread number 5. Very good. Thread number 5 is waiting for thread number 7. And they are going on their merry way. Did my... Okay. I think the keyboard stopped working again. I would recommend this keyboard, but I'm not sure what's going on. If it's the keyboard or if it's Windows or what's going on. But I basically just unplug and plug it in again and it works. Maybe there's something weird with the electricity or something, I don't know. Okay, but let's just see what is going on. So where are we now? You're waiting. Okay, so you're gonna wait. You're streaming, I think, cat, maybe. The last thing, yeah. And there we go. And now, wait, did we get the hello there or no? And you are waiting for the process or no? You're waiting for the process, I think, yeah. Now we can't see waiting for process here because waiting for process is like a blocking, it's kind of like a blocking instruction that goes back to the thread every time, so. And you're gonna stream what? Okay, so this is like echo closed. Removing source, stream disconnected sources. Now, yeah, so now thread 4 should resume, I think. No, thread 5 exits because the execution is done. Yeah. And we get the hello out now because we stream cat. You're still waiting. You're still streaming from cat. Wait, I thought that the thread number 4 would continue at this point. So we never get here, I don't think. This is what we need to get to in order for cat to close. But 4 is like stuck over here, I think. Yeah, we're forking into 5. Yeah, it's waiting, but why does it say waiting for 8? Oh, maybe that's the ID of the thread. Okay, so 5 is the instruction set. 8 is the ID. So it's waiting for 8. But why is 8 is like on 2 though? Yeah, there could be some kind of mismatch between which pipe is which, or which thread is which. This should be the ID of the thread, I'm pretty sure. Waiting for, that has to be an ID because otherwise it wouldn't work. Yeah, it's a thread ID. Yeah. Okay. So that is strange, I think. No, it's not, maybe. Actually, it wasn't strange at all. You know what? Let's do one more thing. Let's print out. Let's print out the current instruction, actual instruction as well. Format, thread, current instruction. Okay. And also, let's do active current instruction address. Current thread, current instruction address. Okay. And then I want to do, when we print the instruction, I want to say no, wait, we don't really need to do that. What we need to do is we just need to get the current thread and I want to just check the ID here, suffix. Another thing, which is going to be like if thread ID is equal to current thread ID, we're going to say executing. Okay, whatever. I thought I would save some. Oops, some letters there, but I actually ended up introducing more. Okay. So now we can see that this is the executing thread right now. Cool. And we forked. Why don't we see that thread? We have two threads. Oh, I see. God damn it. It's the same issue with like skip IO, yeah. Wait, print instructions. I mean, we already solved this issue. So current thread, thread I, thread. Let's just do like get current executing thread. and this would be thread context. Okay, so let's go back here, current thread. There we go. Okay. And you can see here when the instruction is like longer, it breaks, and then the next thing will get printed after. Magic! Yeah, but now there's too much information here. All right. I think that's gonna be it for this time. We've done a lot of upgrades to the debugger, so that's nice. We'll have to think about what we could do to kind of improve this a little bit. But it was really cool to just do some kind of super basic, you know, functions to draw, you know, something on screen so it looks, you know, it's not really a full like window manager or anything like that, but it does its job right now. But I would have to try and upgrade it a little bit more, maybe to see what's going on with the pipe bug there. So we didn't actually manage to solve any bugs now, but the debugger was upgraded a lot, which is really nice. But yeah, that's gonna be it for this time. So thank you very much for joining me here, and I will see you next time, hopefully tomorrow. We'll see, maybe not, maybe yes.